to think about this, before heading straight to the math part, we're going to draw a box. So here is our box. What we're going to do is understand the different forces of the box. The box is going to be pulled by the force of gravity on Earth. That's one of the things we should think about. Then the box is going to be withstood by normal force, the force needed to keep the box upright, because if it doesn't, it will collapse, like a building on fire. The box also is being pushed to the right, and that is going to be the force being applied. The box is also going to be against drag, or should I say friction. So that's going to be the force of friction. If the problem literally states in the so-called problem, if the block weighs 50 newtons, that is going to be from our gravity, so we should put 50 newtons right over there. We also have a minimum requirement of pushing the block 35 newtons to the right. So for our force being applied, the force on the block trying to make it go is 35 newtons. So here is what we're going to do for the first one. We are going to try to find the starting coefficient, the one on the bottom. We're trying to see what is the starting coefficient for friction needed to make the block go. So we got the formula over here, so we have right here. We have 35 newtons right there. That is going to equal our mu. Then we have to multiply that by 50. 50 because that's our gravity, but also that's our normal force. But, we want to get mu alone. Because it's like some kind of variable. So we divide by 50, divide by 50. 35 over 50, it should be our answer. But it's not, because we still need to simplify it down. That could equal to 7 over 10 and get to a decimal 0.7. So the starting coefficient friction should be 0.7 for mu. That's what mu represents in this case scenario. But hang on, what about when it comes to sliding the friction? So we've already solved the bottom one, but what about the top one? Well, since the problem uses the same block and it's telling us to do two different things to solve it, we can still keep this photo. However, since we did this with the other one, we kind of have to redraw it again. So technically the math for this one is the same, because we're trying to find mu alone. If it takes 20 newtons to keep the block going, but the block still has a weight and a normal force of 50 newtons, then we have to find out what our mu is. So what is that? So if we do divide by 50 and divide by 50, we get 20 over 50. Then we have to simplify that to 2 over 5. Then we simplify that as a decimal of 0.4. So the coefficient for friction when it comes to keeping the block going when it moves already is 0.4. And that is how we understand friction force. Yeah, the friction. Hey, let me move this box so we can see the entire page using the friction. So I hope this video has helped you understand the friction force. Thank you for watching Top Analyze Math Industry. Like and subscribe. Friction is extremely important because sometimes we need to slow down. And sometimes we need to grip on things so we don't fall off things. And sometimes we want friction because we just like to. So yeah!